we're gonna enter to the last topic, which is, like we did with rational expressions. We talk about all of these radical expressions. Now let's solve equations with them, okay? So a radical equation is an equation that involves radicals. And what we're going to take advantage of in this case is that when you raise a radical expression, when you have a radical, if you raise it to a power matching the index, it cancels, okay? So note, if you have the nth root of a, and if I raise this to the n power, notice that here the index and the power, they match, it cancels the radical. The radical is gone, okay? Just like before, we did the square of the square root and it cancels the square root. Well, if the index here matches the power, then we'll cancel and you just get the stuff inside. We're going to take advantage of this property. Let me show you an example. Let's solve number 1. So if you have square root of x plus 4 equals 10. Notice that the index, what's the index here? No. What's the index here? It's 2. Remember, we agree that when we don't write anything, there is a 2. It's a square root, right? There's no notion of 1 root, right? So this is a 2, and only if you want to say cube, 4, and so on, root, then you put the number here. You want to say cube root, you put a 3. 4 root, you put a 4, and so on, okay? So when n is 2, we don't write anything here, okay? So this is a square root. So that means that if I want to cancel this square root, I need to square, okay? Now, if you square right here, that's a problem because this is going to be a mess because it's a binomial. So you have to distribute, and it's not going to be gone. So the first thing that you need to do is isolate the square root. So leave the radical alone, and then you square or raise to whatever power you need to raise. For example, here, instead of squaring both sides, I'm first going to move the 4. So we isolate the radical, subtract 4, so you get 6. Okay? So now we are ready, because now we have square root of x equals to 6. So what we can do is we square both sides. Okay? Because the two things are equal. When you square it, it's still equal. And now the left becomes x because the square cancels the square root, and the right becomes a 36. Okay? And you can easily see that if you put 36 here, square root of 36 is 6 plus 4 is 10. So very good. Okay? So, and this is something else. For radical equations, as you will see, you always need to check. Okay? So to check means go ahead and plug in, your answer. Make sure that it works. So we have square root of 36 plus 4, and then we're wondering, is this 10? In this case, yes. And so we got a solution, okay? Because you're gonna see that sometimes you're gonna get something that's not a solution by doing this process. Those are called extraneous solutions. All right, do you understand what I just did? So all you have to do is isolate the radical, and once you have the radical expression by itself, raise both sides to the power matching the index. Okay? That will cancel the radical, and then you solve the remaining equation. For example, let's take a look at number 2. So number 2, that's the cube root of x squared plus 11 equals 3. So in this case, we already have the radical by itself. There's nothing to move, okay? We already have the radical on one side. So what should we do at this point? So to what power do we raise both sides? To the third power. So we cube it. So remember, for the second power, we say square. For the third power, we say cube. After that, we just say fourth, fifth, etc. So the point is that here we're going to cube both sides. Why? Because the index here is 3, so I need to raise it to a power that matches the index, so I can cancel. We want to take advantage of this property. Remember, the idea is to get rid of the radical so we can solve for x. So we want to take advantage of this. The power matching the index cancels. Okay? All right. So when you do that, you obtain then x squared plus 11, right? The radical is gone, equals 27. And now we solve this equation, okay? So in this case, this is quadratic, all right? So there are several ways that you could solve this equation. For example, I'm gonna do it by using the zero product rule. I'm gonna bring the 27 to the left. So if I subtract 27, what do we get? We get 16, right? And then this is a difference of squares. So this becomes x plus 4, x minus 4. And then that means x plus 4 is 0, or x minus 4 is 0. This is what we did in the previous chapter. And so we get negative 4 or 4. Okay? All right. And then, in this case, remember, you always need to check. In this case, it will turn out that both of these are okay. But, let's check it. And the reason is because, the sign doesn't matter because we're squaring the x anyways. So that sign would be relevant for us. But to check, first let's check x equals negative 4. So the question is cube root of negative 4 squared plus 11. Is this the same as 3? Well, let's see. That's the cube root of 16 plus 11. And 16 plus 11 is 27. And indeed, the cube root of 27 equals 3. Because 3 times 3 times 3 is 27. Okay? So negative 4 works. And then hopefully you can see that 4 is going to work as well. Because if I put a 4 here, the square, I'm going to get this line anyway. 4 squared is also 16. And then it's going to work nicely. So similarly, x equal to 4 checks out. Okay? So both of these guys are a solution. Okay, questions? Did you understand this? So again, the strategy is leave the radical expression alone. So move everything else to the other side and then raise both sides to the power matching the index. The radical simplifies and then after that you solve whatever is left. Sometimes it's a nice easy equation, sometimes you have to solve the quadratic, okay? Or something else. It really depends on what's going on with the problem. And also remember that when you have rational exponents, those are also radical expressions. So for example, number 3, there's a 1 over 4 here. This is a radical. This is the 4th root of x minus 1, okay? So let's take a look at that one. So the first step is write as a radical. So you have 3 equals 6 plus x minus 1 to the 1 over 4. So the first thing that we're going to do is write this as a radical. That's the 4th root of x minus 1. We talked about this last week, how to understand rational exponents. Remember, the denominator is the index of your radical, okay? And the numerator is the power of the radical stuff inside. All right. So let's see. What should be the first step here? What do we do? Before that, what do we need to do? We need to leave the radical alone. So what do? We move the 6 over. So subtract or add? We subtract. So we do minus 6. So we end up with negative 3 equals the 4th root of x minus 1. You okay with this? All right. So, by the way, at this point, something you should realize that something is fishy, but let's continue. And then I'll come back and say it. All right. So let's say that we're on. Fine. So, okay, let me just say that now. So notice that whenever you do the square root of something, the result is always positive. Okay? The same thing is going to happen when you cube root is okay, but if you do a 4 root, a 6 root, and any even root, when the index is even, it has to be a positive number. So because we are getting that this equals a negative, right here I can already see this is not going to have a solution. Okay, this is not going to have a solution. So, but anyways, let's say that you don't realize that. We're going to continue solving, and then the problem itself, when you check, it will tell you that there is no solution. That's why you always need to check. Okay. All right. So if we don't make that observation at this stage, and we continue with the process, now the idea is to raise both sides to the 4th power, right? Because we need to match this index. So we raise both sides to the 4th power. On the left, we get -3 to the 4, so it becomes positive 81, because 3 times itself 4 times is 81. And on the right-hand side, we get x minus 1. So this power cancels the radical. And we end up with x being 82, right? So we get x equals 82. Now again, you have to be very careful. So let's go ahead and let's plug in into the original expression. So check. Whenever you solve a radical equation, whatever answer you seem to get, don't say that's the answer and walk away. You always need to check. All right, so notice that line 1 and line 2, they are exactly the same. All I did was rewrite the 1/4 as a 4 root. So I'm going to use line 2, okay? So that would be 3, and we're wondering, is 3 the same as 6 plus the 4 root of 82 minus 1? So I'm replacing x by 82. All right, let's see. So we have 6 plus, now here we have the 4 root of 81. What's the 4 root of 81? Give me a number, so when you multiply 4 times, you get 81. So 9 times 9 is 81, that's 9 squared. But then 9 is 3 times 3, right? So 81 is 9 times 9, yes? 9 is 3 times 3, and 3 times 3. So there are 4 3's here. So if you do 3 times 3 4 times, you get 81. And I told you that here. 3 to the 4 is 81. Okay, the point is that that's 3. All right? So you get 6 plus 3. Now 6 plus 3 is 9. So is 3 the same as 9? No, they're different. Okay? So what does that mean? The left does not equal the right when you plug in 82. So this guy is not good. This is not a solution. Okay? We call this an extraneous solution. So this is extraneous. And because there is no other candidate, then that means that there is no solution to this problem. So, no solution. Okay? So the solution set is empty. So it could be that you end up with a radical equation that has no solution. And, to be able to determine this, that's why you always have to check. Sometimes you're going to have more than one solution, like above, and it could be that one of those doesn't work and the other one is fine. The way to realize this is by checking, okay? You have to plug in and check. It also gives you an insurance that what you did is correct, okay? When you check. All right, questions? Okay, so now let's do one that's slightly more interesting, because so far here, when you raise both sides to the power matching the index, the radical is gone, and we got something relatively straightforward to solve for. But 4 and 5 are, a little bit more complex. So let's see, let's do number 4. That's square root of 3x plus 1. The square root of 3x plus 1 minus x equals -3. Okay? What's the first step? To leave the radical alone, right? Isolate the radical. So what do? So we move the negative x to the other side, positive, right? So our first step, just leave the radical alone. So the negative x goes to the right, positive. Questions? Okay, all right, the radical is by itself. What do we do now? We square both sides. Why? Because that's a square root and we want to get rid of it. Okay? And to get rid of it, we need to square both sides. So we square both sides, then simplify. This cancels the radical, so we end up with 3x plus 1 on the left. Now here, be careful. On the right, we have x minus 3 squared. Understand that this is not x squared minus 9. Okay? Here you need to do x minus 3 times x minus 3. Do the foiling and simplify that. So you do that in a corner. Or remember, I'm going to use this one because it's helpful to use this little formula. If you have a minus b squared, remember that this is a squared minus 2ab plus b squared. So it's the first guy squared minus the product of these two times 2 plus the last guy squared. If you don't want to use this special product, remember we talked about this when we're factoring. If you don't want to use this, then what you need to do is write it as x minus 3 times x minus 3, and then these three will combine like terms and all of that. Okay? It's up to you. Anyways, the point is that this is, and for completeness, let me just say, if we had a plus, it's the same. It's just that everything is positive. Okay? I'll be using this because it's faster. But if you don't remember, that's okay. Just understand that don't just do x squared minus 9. That's not true. Okay? There is all stuff going on. So you need to do x minus 3 times x minus 3, you know, and do the foiling thing. All right? Okay, after you do all that and combine like terms, or you use the formula, you're gonna get x squared minus 6x plus 9. So that's the first guy squared minus the product of the 2 times 2, that's the 6, plus the last guy squared. And now you realize that this is a quadratic equation, so we need to solve it. And to solve it, we need to make it equal to 0. So I'm gonna move everything to the right. So I'm gonna subtract 3. So negative 3 minus 6, that's gonna give me a negative 9x. And then subtract 1, I'm gonna get 8. And right now, you know, I'm going to soon present to you the last thing that we're gonna do, which is the quadratic formula that will allow you to solve the quadratic equation in general. But right now, all we know how to deal with this is by factoring. So hopefully this is something that we can factor. So we can use the zero product rule. So let's see, can we factor this? Two numbers whose product is 8 and the sum is negative 9. So the sum has to be negative. So what are the numbers? Negative 8, negative 1. Good. So this would be x minus 8, x minus 1. Okay? And now using the zero product rule, it means that each of these must be 0. So either x minus 8 is 0, you know, at least one of these guys has to be 0. Otherwise, that product cannot be equal to 0. So we get two potential solutions, x equal a or x equal 1. Do you understand this so far? All right, now, again, we cannot claim that these are the solutions. Before we do that, we need to go back and we have to check, okay? So you can either check visually or literally plug it in and write it down, okay? It's up to you. For example, let's see, I'm gonna plug in 8 and then we're gonna check 1 visually, okay? Yeah, okay. Or let me just plug in both. All right, so I'm gonna check x equal 8 first. So that means square root of 3 times a. Always remember to plug into the original statement. And then we're wondering, is this negative 3? Well, let's see. 3 times a, that's 24, plus 1, that's a 25. So we have here square root of 25 minus 8. And the question is it negative 3? Well, what's square root of 25? 5. So we have 5 minus 8. Is 5 minus 8 negative 3? Yes, it is. So we're good. So x equal a works. Okay. Now let's check x equal 1. Okay. All right. So we have the square root of 3 times 1 plus 1 minus 1, and then we're wondering, is this negative 3? All right, let's see. So 3 times 1 is 3 plus 1 is 4. So here we have square root of 4 minus 1, and we're wondering this. So what's square root of 4? 2. So we get 2 minus 1. Is 2 minus 1 the same as negative 3? Well, let's see. What's 2 minus 1? 1. Is 1 the same as negative 3? No, it's not. So what does that mean? It means that this guy is not a solution. Okay? Remember, we call it extraneous. Okay? So x equal 1 is not good. X equal 8 is okay. So we only have one solution, namely 8. So if you don't check, you won't be able to detect this. That's why when you solve radical equations, you have to check. You have to plug in into original equation and see. Sometimes one of the solutions that appear is not going to work, or sometimes they all work. Like in case number 2, we got 2 solutions and both of them were okay. All right, so you have to check. Okay, questions? So, and then number 5 is, notice that so far we have dealt with only one radical in our equation, but there is no reason for that. There could be more than one, like in here. In this case, we have 2 radicals. What's going to happen here is that we're going to have to square twice. We're going to need to do this process 2 times. So first, we're going to isolate one of the radicals. We're going to square to get rid of that radical, but the other one will survive. Then we need to do the same process, isolate the remaining radical and square again. Okay? We basically have to do this process twice. So let's do it. So 5x plus 1, square root of x plus 1 minus square root of x. So square root of 5x plus 1 minus square root of x equals 1. All right, here we go. So again, same idea as before. It's just that we need to take care of one radical at a time. Okay? It's not a good idea to square at this stage because then the left-hand side is gonna be a super mess. It's just gonna get more complicated. Nothing will cancel, and then it's gonna be worse. So the first thing that we do is leave one radical alone, whichever you want. I always like to have positive stuff, to leave the positive stuff on the left. So that negative square root of x, I'm gonna bring it to the right by adding. So we're gonna eliminate this radical first. Okay. All right. So I have the square root of 5x plus 1 equals 1 plus square root of x. Just move the negative square root of x to the right hand side. Now at this point, we're going to square both sides. By doing that, this first radical will be gone, the one on the left, but the one on the right will survive. Okay? So we need to simplify and then isolate that radical that survives and then repeat the process. All right, so let's square both sides. This way at least we get rid of one of the radicals. So here we have 5x plus 1. Now on the right hand side, remember, it's not this square plus this square. You either multiply this by itself or use the formula that I presented to you above. Okay? I'm going to use that formula. So it's the first guy square plus the product of the 2 times 2. So it will be 2 square root of x plus the last guy square. So when I do a square root of x squared, that's just x. Okay? Again, if you don't want to use the formula, just in a little corner, you write this down, and then you do it. Okay? Just multiply by itself, because that's what the square means. Let me show you quickly. So it will be 1, when you distribute, 1 plus square root of x, and then plus the square root of x plus x. And that's how you get this. Okay? When you combine these 2 square root of x, you get 2 square root of x. All right. So notice how one of the radicals was gone after this first step, but the other one survived. It didn't go away. So now we need to leave this one alone, this term alone, and square again. Okay? So let me move everything to the left that doesn't have the radical. So this guy and this guy, they're gonna go to the left. Let's see, if I subtract 1, and then I'm gonna subtract x on both sides. So what do we get on the left? I'm gonna have 4x. The ones cancel nicely, so that's good. And then on the right hand side, I have 2 square root of x. Notice that here, because this is a 4 and this is a 2, I could divide both sides by 2 and lower my numbers. So whenever you can do that, it's a good idea. If instead of a 4, this would have been a 5x, I would not do that because then you have to deal with fractions. If you divide by 2, the 2 is not going to cancel and then you have to deal with the fraction. But because 4 is even, it's nice, so I'm going to divide by 2 also. So I get 2x equals square root of x. And now that the radical is alone, I'm going to square both sides one more time. By doing so, remember when you square a product, you have to square each of the factors. So 2x squared, that becomes 4x squared. And then square root of x squared, that's just x. And now this is a quadratic, we solve it. Remember, for quadratic equations, we need to set it equal to 0. And we factor now. So in this case, we can take common factor x. And so this becomes 4x minus 1. And so either x is 0 or 4x minus 1 is 0. So from here you get that x is either 0 or 1 over 4. Just move the 1 over and then divide by 4. So, questions so far? Do you understand the idea? Leave one radical alone, square both sides, simplify, there will be one radical remaining, isolate it, square again. Okay? And then, once there are no radicals left, solve whatever you have. Okay, so now we need to determine which one of these work, okay? Maybe both, or maybe one of them doesn't work. So we need to go ahead and we need to plug in. So let's check. All right, so first, let's see, 0, we can check it visually. If I were to plug in 0, what are we gonna get? If I put x equals 0, 5x is gone, yes? And then you get square root of 1, which is just 1. And the 0 here. And then if I put 0 here, this is gone, okay? And then you get 1 minus 0, which is 1. So that one is fine. So x equals 0 is okay. X equals 0 is fine. Now for the 1 over 4, let's plug it in. So let's check 1 over 4. So we get the square root of 5 times 1 over 4 plus 1 minus square root of 1 over 4. And we're wondering, is this 1? Okay, let's see. So 5 times 1 over 4, that's 5 over 4. And then, what's the square root of 1 over 4? That's 1 over the square root of 4, which is 1/2, right? Because square root of 4 is 2. And we're wondering, is this 1? Okay, so let's see, 5 over 4 plus 1. Remember, we need to have the same denominator. So this 1, I'm going to multiply top and bottom by 4. Okay, so I have a 4 over 4 now. And we can nicely combine because denominators are the same. So 5 plus 4 is 9. So we get the square root of 9 over 4 minus 1/2. What's the square root of 9 over 4? What is it? So 3/2, right? So 3 over 2. Okay, good. So we get 3 over 2 minus 1 over 2, and we are wondering, is this 1? Okay, can we nicely subtract these two guys? The denominators are the same. So 3 minus 1? 2. So we get 2 over 2. Is 2 over 2 the same as 1? Yes, so we're good. So this guy also works. Okay, so again, you have to check, because it doesn't mean that one is going to work, the other one won't. It could be that both of them work, as you saw here. So this time we found two solutions, namely 0 and 1/4. Okay, questions? So this is how you solve. I mean, I guess I would say number 5 would be like the most complicated case that you're gonna see. Okay. So if you understand how to do number 4 and number 5, you are more than good. The other ones, I'm saying that they are not that complicated because you only have to square ones or raise ones to a power, and once you do that, what you obtain is something straightforward because here you only have a number. But the moment that you have a binomial on the right, like number 4, when you square, you have to be careful with the algebra because now you need to square this term and then you could make mistakes here and so on. Okay? So 4 and 5 are the ones that you have to be more careful about. Okay. Questions? Are you okay with this? All right. So those are radical equations. And then, by the way, what I'm about to say now, that would be the first thing that you're going to start doing in college algebra. Okay, in college algebra, you're going to start talking about complex numbers and revisiting quadratic equations again. So what I'm going to do now is give you a quick overview, just something very quick of what complex numbers are, and then we're going to use that to be able to solve quadratic equations. Instead of going through all the different methods, you already know how to solve quadratic equations by factoring. I'm going to go ahead and give you the quadratic formula. And then you just need to remember that formula. You just need to learn that formula, and then you learn how to use it. That's all. Okay? So once you know the formula, solving a quadratic equation should not be a problem anymore. But you need to know the formula and understand how to use it. But let's develop to get there. Okay, so our goal is to solve quadratic equations, okay? Any quadratic equation. That's an equation that looks like this. And here, A, B, C are real numbers. And of course, A is different than 0, because if A is equal to 0, we don't have an x squared, okay? And so the moment that we are saying, okay, we want to solve any quadratic equation, then we need to stop a second and say, okay, let's look at this one. This is a quadratic equation. It's a very innocent one. X squared plus 1 equals 0, okay? That's a quadratic equation. So we don't get our hopes too high just yet. If we're trying to solve this one, then we could play the following game. Oh, this is the same thing as saying that x squared is equal to -1, right? Moving -1 to the right. A positive 1 moving to the right becomes negative. So what do we immediately see here? If we are hoping to have a solution, this solution has to satisfy the following. When you square it, it will give you a negative. And what do you know about real numbers? What happens when you square a real number? Would you always get, can you get a negative by doing the square of a real number? Let's see. Positive times positive is positive. Negative times negative is also positive. So there is no way to multiply a real number with itself and get a negative. So we immediately realize that if we're hoping to solve any quadratic equation, we need to accept the fact that there are numbers out there other than real numbers. Because the real numbers, the ones that we have been dealing with so far, they don't solve this equation. As far as the real numbers are concerned, there is no solution here. Okay? There is no real solution there. Now, we want to make sense of this because we want to solve any quadratic equation. So for this, we need to introduce a new type of numbers. Okay? So if you wanted to solve this, then naively you would say, okay, x is something whose square is -1. In other words, -1 is the square root of, so x is the square root of -1. Remember, square root means something so that when you square it, you get the number. So what we're saying here is, then you could say that, okay, this means then that x is the square root of -1, and there could be two possibilities, the positive and the negative. Because when you square both sides, the square kills the positive and the negative. But remember the problem that we encountered at the very beginning, that this is not a real number, right? So you all know. That's why we didn't say it does not exist. We just say this is not a real number. So this is actually the birth of a new type of number, okay? So this is a symbol, a square root of -1, and we're gonna call this the imaginary unit, okay? So we call that symbol, we call it I. So I stands for the square root of -1, and it's called the imaginary unit, and its property is that if you square it, you get -1. So now we have something so that when you square it, it's a negative, okay? Namely -1. That's called the imaginary unit. And the moment that we introduce this symbol, this is just a symbol, okay? Then we can form a new type of numbers. There is the notion of an imaginary number, okay? An imaginary number. And that's basically just a real number multiplied times this symbol I. So for any real number A, the number A times I is called an imaginary number. As an example, as an example, think of it as like 3i, -2i, 1/2 I, whatever you want, okay? Any number times I, now it's no longer a real number, this is called an imaginary number, okay? And then you can now put imaginary numbers together with real numbers, and we can form what we call a complex number, okay? So for any real numbers A and B, we can form the following expression, A plus BI. So you have something in your mind, for example, 2 plus 3i, okay? When you see something like this is called a complex number, okay? And 2 and 3, they are real numbers. 2 is called the real part, and 3 is called the imaginary part. So for any real numbers A and B, this expression is called a complex number. And A is known to be, is called the real part, like in the example, that means 2 is a real part. And B is called the imaginary part. So in this example, the number 3 will be the imaginary part because it's the one that's next to the I. Okay? So these are a new type of numbers, and then of course there is a question, okay, is this a number you should be able to add, subtract, multiply, divide? All of that, that's what you're going to start doing in college algebra. When you begin college algebra, you're going to start with these complex numbers, and then you're going to talk about the arithmetic of them. How do you do operations? But we are not going to concern ourselves with that right now. I just want you to be aware of their existence because they naturally show up as solutions of quadratic equations. As you can see, this I is showing up here. That's how we're using it to define it. All right, so any questions about what this I means? All I want you to understand is that I is a symbol and it's equals to the square root of -1, okay? So it's something so that when you square it, you get -1. Do you have a question about this? All right, so once you have this, then, we can solve, because now if you want to solve x squared plus 1 equals 0, okay, move the 1 over, and then we're going to take square root. Let me pause here for a second. Imagine that you have this question, x squared equals 9. We could do this the old way, which is move the 9 over, and then you have x squared minus 9 equals 0, factor difference of squares, and you get your solutions. But we can do this a little bit quicker. X is something whose square is 9, so that means x must be the square root of 9. Do you understand this? But remember, there are two possibilities, the positive and the negative, because when you square, the negative is gone. This is called the square root method, okay? So whenever you have something squared equals a number, you can just get rid of the square by taking square roots, but you have to put plus or minus. So here we get that x is plus or minus 3. In other words, there are two solutions here. X equals 3, x equals -3. This is called the square root method, okay? And it's a quick way to solve quadratic equations when they are simple like this. You just solve for x squared equals to a number, and then you take square root. And then remember to put the plus or minus because there are always the two possibilities. So this same idea, we can use it over here. If x squared equals -1, then that means that x is going to be plus or minus the square root of -1. Now we do have a meaning for this. The square root of -1 is I. It's this imaginary unit that we just introduced. So we get that x is plus or minus I. So we get two solutions here, x equals I and x equals negative I. So typically we combine the two as one and we put plus or minus like this, but understand that there are two solutions here, one with the positive and one with the negative. Okay, questions? All right. So before I show you the quadratic formula, let me now tell you that now we can make sense of square roots with negatives inside. We can now simplify those. You just need to understand. So before, a couple of lectures ago, when we saw something like number 1, what would we say here? If I ask you to simplify this, you say not a real number and move on. You don't do that anymore, because now we know what's going to happen here. This is going to be an imaginary number. Okay? Now, how do we simplify this? Let's see. I'll show you the first one. Basically, the idea is the following. Negative 25, you can write it as 25 times negative 1. Yes? Using the properties that we know, this is the same as square root of 25 times square root of negative 1 by splitting. What's the square root of 25? 5. And what's the square root of negative 1? I. That's what we just defined. See this? This is the imaginary unit, right? By definition, every time that you see square root of negative 1, that is this symbol I. So that equals 5I. So this is what's happening behind the scenes, but typically we don't write this down. And when you see something like this, all you do is, okay, the negative, you can remove it, but then you have to write an I outside, and then you simplify the radical without the negative, okay? As simple as that. So for example, in number 2, I see a negative. I already know that this is going to be an imaginary number. So this is just the square root of 7 times I. So the negative becomes an I outside. It's an imaginary number. And then the imaginary part is the square root of 7. Because we cannot simplify square root of 7 anymore. We just leave it like that. Okay? Let's see. Number 3. The first step is that I see that there is a negative. And then that means, okay, I'm going to have an imaginary number as a result. So this negative is going to produce an I outside. So immediately write this down. Okay, that's because of the negative, because that's a square root of negative 1. Okay, but now our job is to simplify this. Can we simplify square root of 18? Yes. How? What do we do? We did this last time. What do? We write 18 as 9 times 2. 9 is a perfect square, so it comes out as a 3. And 2 stays there. So that's 3 square root of 2I. Okay? So that's a number, so that when you square it, you get negative 18. Remember, these are imaginary numbers now. So now you can make sense of square root of negative numbers. Just understand that the answer is not a real number anymore. It's what we call now an imaginary number. Questions? And the reason why we're talking about these guys is because they naturally arise when you're solving, quadratic equations. Here is the simplest quadratic equation you could write, and the I is popping there in our face. Okay? So we cannot avoid it. And then, to complete this, let me just give you the quadratic formula, which is a formula that you can use to always solve a quadratic equation. Any quadratic equations that comes your way, all you have to do is be able to successfully simplify. Okay? All right, so let me write it down. So here's the theorem. In college algebra, you're going to talk about this again, and you're going to see where this formula comes from and all of that business. Okay? You're going to learn the method of completing the square, which is what you need to be able to arrive to this formula. And for the sake of time, I will just present the formula to you. So let's see. The equation ax squared plus bx plus c equals 0, right? That's any quadratic equation. Has the following solutions. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So again, this is something that you need to know, that you need to learn, like memorize it. And then every time that you have a quadratic equation, all you have to do is take the coefficients A, B, and C, put them in this formula, and it will tell you a solution. Notice that there are two solutions, one with the positive, and then another one with the negative in here. Okay? Now, if you take a look at this expression here is important. We call that the discriminant. Okay? So b squared minus 4ac is called the discriminant of the equation. I'll tell you now its importance. So if we call that letter D, then this equation will look like this. Negative b plus or minus the square root of the discriminant divided by 2a. And the reason why that number is important is because it tells you a lot of information about the equation before you even solve it. Let's say that you are not really interested in what the solutions are, but what type of solutions you're going to get. Like, for example, am I going to get two real numbers of solution? Am I going to get complex numbers or imaginary numbers? Am I going to get only one solution? Well, this number, the discriminant, tells you. Okay? For example, if when you compute the discriminant happens to be a positive number, what's going to happen? You're going to have a positive number inside this square root, and that's going to give you a real number. And then you're going to have two solutions, one with the positive and another one with this negative down here. Okay? So if the discriminant is positive, then the equation has two real solutions. So two distinct real solutions. So the two solutions are real numbers. Okay? Remember, discriminant is a number, so there are three possibilities for any number. It's either positive, negative, or zero. Okay? So I'm telling you the three cases. If it's positive, you know you're going to have two distinct real solutions. Now, what if the discriminant is zero? Well, if the discriminant is zero, the square root of zero is just zero, so this disappears, and you only have one solution, negative b over 2a. Because now the plus or minus doesn't matter because you have a zero here. So if the discriminant is zero, that means that the equation we have has one real solution. That means the solution is a real number and there is only one. And then the other case is if the discriminant is negative. A negative discriminant will mean that you will have a negative number inside this square root. And as you know, if you do square root of something negative, now imaginary numbers are going to pop up. And because they are combined with all of these real numbers here, we call it a complex number. Okay? So if the discriminant is negative, then the equation has two complex solutions. Okay? So again, you're going to look a little bit deeper into this once you are in college algebra next semester. But this is a nice number to know because it will tell you what type of solution to expect beforehand. And also it will speed up your computation of the solutions because it's nice to compute this discriminant first, and then once you have it, you just put it in here instead of having a big mess in your formula. All right, so let me show you how to use this. Again, the key here is in obtaining your A, your B, and your C, okay? And then, of course, knowing the formula. So the first thing is that you have to make sure that your equation is set equal to 0. So, and we may not be able to solve all of these equations at once, but let's do as much as we can, okay? I'm just going to use the formula right away to solve all of these equations. When you have a quadratic equation, you should try to see if you can factor first. Most of these examples here, also you cannot factor. The last one you can factor. But for example, this one you can't. Two numbers whose product is 2 and the sum is 2. You're not going to be able to find it, okay? So your only hope here is to use the quadratic formula, for example. Or a technique called completing the square. Anyways, here let's use the quadratic formula. So solution, for the first one we have x squared plus 2x plus 2 equals 0. So first job is to identify the coefficients a, b, and c. So let's see, what are the coefficients? Remember, a is a number in front of x squared, b is a number in front of x, and c is a number that's by itself. So what are the values of a, b, and c in here? 1, 2, and 2. Okay? So the next thing that we're going to do is we're going to write down the discriminant. So remember, the quadratic formula, let me put it here. So quadratic formula, it says that the solution is going to be negative b plus or minus the square root of b squared minus 4ac over 2a. This part right here, I'm gonna call it D for discriminant, okay? So I always like to compute this piece here first, so I know what to expect, and also then when we use the formula, we have something clean. You just put a number here instead of this big expression, okay? And then you can make mistakes, simplify. So let's compute the discriminant first, which is b squared minus 4ac. At this point, just put your numbers. So as 2 squared minus 4 times 1 times 2, okay? So this gives me 4 minus 8, which is negative 4. So we have a negative discriminant. You already know that because this number is negative, you are expecting complex solutions, okay? So there are not going to be real solutions. The solution will be complex numbers. There has to be an I in your solution. All right, so let's find them. So now we put the formula. I'm going to put the simplified version, which is negative b plus or minus square root of d over 2a. Remember, d is this number that we just computed. It's all of this, okay? All right, so as negative 2 plus or minus square root of negative 4 over 2 times 1, and just compute. What's square root of negative 4? Well, that's the square root of 4. What's square root of negative 4? No. What happens to a negative? It becomes an I. That's what we just did here. You see what we did here? When you do square root of a negative number, it becomes imaginary. The square root of negative 25 is 5i. So square root of negative 4 is 2i. All right, so it becomes 2i over 2. And now we're going to simplify this. So understand that here, okay, so in this case we can continue. This is a fraction. I can split it and divide each piece by 2. So the 2's cancel. So we end up with negative 1 plus or minus I. Now understand that there are 2 solutions here, okay? One with the positive, so the solutions are negative 1 plus I, and then one with the negative, negative 1 minus I. Those are the 2 solutions. They are complex numbers, okay? Remember A plus BI. This is the real part and the imaginary part is the coefficient of I. And by the way, this will always be the case. You get 2 complex solutions because the discriminant is negative, but notice that they are conjugate to each other. Notice that they look the same, because the one is with a plus here in the middle, the other one is with a minus. That's always the case. If you get a complex number, its conjugate will be a solution. You will learn that in college algebra for actually any polynomial. Okay, questions? All right, so that's how you use the formula. So let's see, let's do number 2. So number 2 is 3x squared. Again, I am doing it, and I'm not telling you to do it on your own first because of the sake of time, okay? I just want you to have all of these examples so that then you can practice yourself at home, okay? You watch the video again, the recording, and then practice so that you understand how to use this formula. Remember, step number 1, set it equal to 0. This already set equal to 0. Good. Next, find the coefficients, A, B, and C. So what are they? A, B, and C. 3, 2, and negative 8. Good. You have to include the negative with it. Okay? All right. Next, we're going to compute the discriminant. That's b squared minus 4ac. Let's see. This is going to be 2 squared minus 4 times 3 times negative 8. So what is this? That's 4. Now notice that negative times negative becomes positive. So 4 plus, now we have 12 times A is 96. So 4 plus 96, that's 100. Okay? So as a positive discriminant, this is telling me already that I'm going to have 2 real solutions. Okay? And again, you can note that from this result. The sign of the discriminant tells you what type of solution to expect. All right, so let's write down the solutions. So x is going to be, the formula is negative b plus or minus
square root of the discriminant over 2a.
Remember, the big version of the formula is instead of writing a d here, you put this expression, b squared minus 4ac, okay? Because we already computed,
Using the short version. So now plugging in, we get negative 2 plus or minus square root of 100 over 2 times 3. So that would be negative 2 plus or minus 10. Square root of 100 is 10 over 6.
And now we need to simplify. So at this point, it helps
to write this as the two solutions. So remember that there are two solutions here. We have one with the positive and one with the negative. Okay, so here is one
with the positive, and then the other one with the negative. Okay, that's just a shorthand of writing the two solutions at once. And now simplify accordingly.
So for example, over here we get negative 2 plus 10, that's 8. So we get 8 over 6. And in this case, we can simplify this more. We can divide by 2. So we get x is 4 over 3. That's one solution. And then on the other hand, for the other one, we have negative 2 minus 10, that's negative 12. So we have negative 12 over 6, which is negative 2.
So when this happens, that you get rational numbers as solutions, that means that we could have done this problem by factoring. So if you use the AC method, you would have been able to factor this and solve the equation. Okay? And now the quadratic formula takes care of this and find the solutions for you. For example, if you put this formula into a computer or your phone to find the solutions, this is what they do. They just put it in the formula and it spits out the solution. Okay, questions? All right, so let me do one more. Let's see, which one do I want to do? Let's do number 4. So number 4 is x squared minus 10x plus 29.
So that's number 3. Number 4. That would be x squared minus 10x plus 29 equals 0, right? Yes.
All right, so again,
all you do is write down your coefficients, a, b, and c. So here this is 1, negative 10, and 29, okay? And then let's compute the discriminant. B squared minus 4ac. So that would be negative 10 squared minus 4 times 1 times 29. So that's 100 minus, and then we have 4 times 29. That's 116. So that's negative 16.
So what type of solution are we expecting here?
We have a negative discriminant. What does that tell you? Complex solutions. Good. So negative b plus or minus square root of d over 2a.
Now here, be very careful. So far, all our examples had a positive b. Notice that now b is negative. Okay. Now the formula itself has a negative in front of the b. So when you put a negative, you're gonna have minus minus. Okay.
So that's very important because those negatives will cancel. So that's negative 10 plus or minus square root of negative 16 over 2 times 1.
So step number 1, make sure that you remember the formula and you plug in successfully. Step number 2, you need to know how to simplify. If you know the formula, but you cannot simplify this, then you're not doing anything. Okay?
Because you won't be able to get to the answer. So make sure that you understand how to simplify this. All right, so negative, negative, that's positive. So that's 10 plus or minus. What's the square root of negative 16? 4i. Good. You will get used to it.
Remember, in college algebra, it's going to be left and right.
It's going to be showing up all the time.
And now,
distribute with the 2 because that's a sum. So that would be 10 over 2 plus or minus 4i over 2. And we can simplify here, and we get 5 plus or minus 2i. So we end up with two solutions, namely 5 plus 2i and 5 minus 2i. Once again, notice that they're conjugate.
You see the same thing, but one positive, the other one negative.
This is always the case when you get complex solutions. All right, so I think with this you have enough examples. If you do number 5 on your own, I'm gonna leave this one to you as a homework. You will see that it's gonna have one solution. So do 5 and 3 on your own. Okay?
But if you compute the discriminant here, you're gonna get 0.
That means there will be only one solution. Okay?